Quickly going through the spiral matrix problem. So spiral matrix is a problem where we need to traverse the array in a spiral format. So starting from some node and going to some other ending node. So now spiral is like we traverse the whole layer and then traverse the another layer, then traverse the another layer, changing directions. So each layer is defined by some direction. Now there are many ways to go about it. One would be like a normal cell to cell transition using the robo simulation fashion, wherein we go to each cell and check if that cell is valid. If not, we just change the direction and go to the next cell. If that is valid or not. Now the validity depends on two things. One, if it goes out of bounds, the I and j. Second, if it encounters another visited cell. So visited cell also can be of two types. Now if they have given that minus 300 to 300 as the values of the nodes, then we can directly change that value to something which is not in the range, so that if we encounter something not in the range, we will know that we have visited that cell earlier. But this given the fact that we are allowed to change the input. If we are not, then we'll have to create a visited array in this particular approach. Second approach is O of 1 approach, where O of 1 space complexity approach, in fact, wherein we already have the guardrails as top, left, bottom and right. Now those boundaries will change after we traverse each layer. Now if we traverse the first layer, we will increase the top boundary from 0 to 1. If we traverse the rightmost layer, we will decrease the right boundary to by 1. Similarly, the other boundaries also we will be shifting. Now these boundaries will give us the particular fact that we know now what we have visited, like what is the direction basically, and what we have visited or not. That context is also present in this directly. So these are the things. One important thing that I noticed in editorial was how to represent the directional array. Directional array can be like 0 1 1 0, a pair of ends, or else somebody also in a 1D fashion they had though it is constant space complexity if we consider for both, like this one also and this one also. For both of them it is constant space complexity only, because it is like 5 elements over here, and then over here it is 8 elements. But in 1D fashion also we can just represent it. The clever thing was that 0, 1, 1, 0, each subsequent, the particular array index and the subsequent array index value, that making a pair. Now over here if you can see that making a pair, that is good that I noticed this one. It was nice. Then the guardrails, some things that we need to remember is how to make these guardrails more efficient, and just remember it so that in an interview like we do not spend much time. Top left 0 0, right bottom -1 -1 from the m and n's, rows and columns. Okay, next thing, in the while loop, first thing we will do is we will check if the left is less than equal to right, or else the top is less than equal to bottom. Equal to is important over here. If they both cross, only then we will say that that particular cell is non-traversable now, right? And these both cases should pass always, right? If any one also crosses, then we'll say that we have completed our traversal. Now particularly for each direction we will run a layer kind of a loop. So for each direction I will run a layer. So for that layer I will run a for loop again inside that if direction equal to 0, then I will run a for loop from I equal to left to right for the first direction. From left to right I will go, and equal to is there importantly over here also. I is less than equal to r. Then next I will change the boundary of the top, because we have traversed that layer already, right? It is visited. I'll change the boundary of top. Then I will change the direction also. I will change the direction to +1 modulo 4, which is the similar to the one wherein we have the robo simulation fashion, right? Similarly for 2 also same thing we'll do, but the top, bottom and the eyes will change. Just that. Main thing to note that in 2, when the direction is 2, right, at that time the greater than equal to is also there in R. Like from when I'm going from right to the left, right, so I'm going from right to left over here. When I'm going from right to left, I'm doing a minus minus, and I'm over here also I'm considering equal to, greater than equal to, everywhere greater than equal to, and the starting should be -1 say initialized. And all the three, 1, 2 and 4, same template it will follow, spiral matrix, and we can solve it. Order of n square of time complexity and order of 1 of space complexity. Next, in the spiral matrix, if we take 3, 1, in that we can start from anywhere in the array, and then we have to traverse like we are starting from the inside to outside. There it was outside to inside. Outside to inside is easier because we know the guardrails and stuff. Inside to outside is a bit trickier because we wouldn't be knowing if we have traversed something or not, right? So here the clever thing from inside to out, or the observation, is that for each 2 steps that we encounter, so first we will process something, and then after processing that only, like we'll have to do for steps, right?